Very good morning to all of you. Today I want to explain about module 1, and title of the module 1 is subsurface exploration of session 1. So this module 1 course outcome is given ability to plan and execute geotechnical site investigation program for different civil engineering projects. Subject title is Applied Geotechnical Engineering and the subject code is 18CV62 of 6 semesters in civil engineering departments. Contents of today's session 1: definitions required to explain, exploration program, methods of exploration, phases in subsoil exploration. So these are the contents are required to explain in details about subsurface explorations today's session 1. Definition of subsurface exploration: the selection of the type and depth of the foundation, the bearing capacity and settlement analysis, and the determination of the earth pressures all depend upon soil properties. The field and laboratory investigations are required to obtain the necessary soil data for design are called soil exploration. Soil exploration is not only needed for the design and construction of new structure, but is also needed sometimes for remedial measures if a structure starts cracking due to settlement. What are the exploration programs are these? Let us see. Here, the objectives of an exploration program are following are the objectives. Okay. First objective is determination of the extent in the horizontal direction and thickness in the vertical direction of the earth type of soil up to the required depth. Determination of the groundwater table below the ground surface. So this is also most important objectives. Next objective is obtaining of samples of groundwater, soil and rock of a size and condition adequate for positive identification of the materials in this site. Next objective is field observation and testing for evaluating the in situ soil properties to substantiate the laboratory determinations. Next objective is, in case the survey is meant for exploring the sounding of material, it is essential to collect data regarding cubic content of each deposits. So these are the objectives of explorations programs made. Next, what are the methods of explorations are this? There are many methods of subsurface exploration. These methods can be classified into 3 categories: semi-direct methods, direct methods, indirect methods. So these are the 3 methods are there for soil exploration. Semi-direct methods I want to explain in details. The semi-direct methods include all operations that involve drilling of boreholes into the ground for purpose of taking out the samples. To collect the sample from the boreholes, option semi-direct methods are applied. There are different options in semi-direct methods: auger borings, displacement borings, vast borings, percussion drilling and continuous sampling all fall under the category of semi-direct methods. So these are the different methods are available for collecting the soil samples in the fields. It must be understood at this stage itself that the advance of boreholes and taking of the samples are two separate through interconnected process. What do you mean by direct methods? The direct methods include the digging of trenches and trail pits. Accessible borings are also included in this category. It is called direct methods. Indirect methods. What do you mean by indirect methods? In these methods, geophysical methods and soundings or probing fall into indirect methods. Means these two methods are comes in indirect methods. One is geophysical methods, second one is soundings methods. What are the phases are there subsoil explorations? So there are so many phases are there. The subsoil exploration involves four distinct phases. First one is fact finding and geology survey. Second phase, reconnaissance exploration. Third, detailed explorations. Next, special explorations. So these are the phases of subsoil explorations in the field. Let us see first phase, fact finding and geology survey. Before the actual explorations at site are started, it is always advisable and beneficial to know the geological history of the area from the geological reports and maps. Soil survey maps of the area are also sometimes available, and they can help in providing information about the soils that the engineer may encounter in the fields. So based on these soil maps, based on geological map, how sites are there that can be identified. The geological survey means subsurface explorations and sampling which will provide information regarding depth to groundwater, pressure of groundwater, sequence thickness, extent and approximate identification of encountered strata. So this includes collection of samples of groundwater, soil and rock in different quantity and conditions for positive identification and laboratories tests, and second one, making observations and for field tests to determine condition of samples and to estimate physical properties of the subsoils. What do you mean by reconnaissance survey? The main objective of this phase of exploration is to obtain a rough idea about the soil type in the area. A rough profile and representative sampling of the major soil strata may be aimed during the operations for this phase. Groundwater table must also be located during this program. Geological methods are helpful in the preliminary exploration of large and medium sized projects, as these methods are quick and cheap. With proper interpolation, data from these methods can be directly used in design. However, it is always a good practice to supplement data with trail borings. So here some suggested spacings and depth of boreholes and spacings are given in table 1. Okay, so in these tables, so column 1 is explains of types of jobs. Column 2 is explains types of soil in horizontal strata and minimum number of boring at each jobs. So how samples are collected, these tables are explained. If your structure is 1 or 2 story structures, the type of soil in horizontal strata is 50. Distance between boring in meters means one place to another place you consider 50 meters, so one point to another point. Okay, next is 25, next 10 to 15 meters, and minimum number of borings at each jobs are 3. If job is multi-story structure, so then 30 meters boring to boring, minimum is 15 meters, or 8 to 10 meters. So here 4 minimum borings are required. Bridge, pier and abutments is required to construct. So then distance is 20 or minimum is 10 meter, 1 or 2 for each foundations. Next, highways and airports. If the project is highways and airports, from boring to boring space is 300 meters or 150 meters or 100 meters. Next, depth of exploratory for boreholes for buildings. So here width of buildings in meters, size of the buildings in meters, these are the number of story. So boring depths in meters. So this table is explained based on the width of the buildings, how many number of samples are required at different depths. So this table B is explains, and these are the examples of how samples are collected. So this figure 1.1 spacing for boreholes for subsoil investigations. This is for normal buildings. So here see this figure 1. So these are the different boring at a distance 15 meters in this direction and in this direction 15 meters, or 8 meter center to centers, or see these figures 120 to 50 meters, 150 in these directions, or fourth case is 30 meter intervals. So these are the examples given for normal buildings. Next, the required depth of exploration depends upon the size and type of proposed structure and the design considerations like safety against foundation failure, settlement, seepage, earth pressure, etc., and the character sequence of the substructure surface strata. However, if an area is known certainly not to contact a clay or silt layer, it is generally sufficient to explore up to 6 meter to 8 meter depth depending on the size and weight of the structure. If the structure is made of a number of substructure, the size of the area occupied by the group does not matter, as each one of them settles almost independently and the compressibility of sand strata decreases rapidly with increasing depth. The depth shown in figure 1.2b generally should be used as a rough guide and should be notified to shoot a particular zone. So these are the sketches are given for different structures, how samples are collected. So this structure is, this is footing at a depth Z, stress due to point P, and we are collecting the samples in clay. This is for depth is required D equal to 2 times B if sandy area. If highway embankments, you collect the sample at a depth 2 to 3 meters. If sloped structure, you collect the sample at 2 to 3 meter depth. If embankments, boring hard strata, so then you select the sample at a depth of W by 2. W is means your width of embankment. And your structure is concrete dam. Then you collect the soil at a depth of D equal to 1.5 to 2 meters. If your structure is retaining walls, so okay, then you collect the samples 0.75 to 1 meter or is equal to 2 times h. Okay, this your structure is tunnel, so then you collect the sample at a depth of d equal to b. So these are the depth of exploratory borings examples are given. Next, detail explorations. The purpose of the detail explorations is to obtain comprehensive soil profiles and representative soil samples of the important deposits. This helps in lowering deposits of good construction materials. Sometimes undisturbed samples of the soil strata are also taken during this phase and sent to the laboratory for testing. Test pits and trenches are usually dug for shallow foundation. Any one of the semi-direct methods can be used for these exploratings. Let us see spatial explorations. Spatial explorations are carried out to obtain undisturbed soil samples from the critical soil layers. The samples are usually 10 cm in diameter. Accessible borings for usual inspection are drilled during this program. Field tests, if any required, to be conducted or carried out during this phase of investigations. Next, power driven augers, vast borings, percussion and rotary drilling methods are employed to advance the boreholes. Pore water pressure is determined in the materials of low permeability, and piezometer or hydrostatic pressure cells are employed for this purpose. Consolidation characteristics of a clay layer, unconfined or triaxial compression strength of a soil, and direct or torsion testing of a soil is done on the samples obtaining during this phase of investigations. So these are the references are made for session 1. Thank you one and all. Next class I will be continuing.